right, it's 12:01, and we seem to have at least a large part of our usual crowd online. So, to the student commenters, moderators, it's your show.
Great, so welcome, and I'll tell you a bit about last week's session. So last week, Heather took us to South America in search of new proxies for El Nino. There we sampled the local flavors of El Nino until we homed in on Potocki. We learned that Potocki may have left a bitter taste in the archaeological record because people tended to rely on drought-resistant food sources during these events, such as lizards, which may show up in the archaeological records, as this would shift the isotopic composition of those that ate them. As people switched to Potocki diet back then, nowadays we may need to avoid climate hazards by switching to a modern Potocki diet, perhaps going light on hydropower and planting drought-resistant crops during these phases. Next, Ian took a plunge into core decision-making while searching for paleoproxies. His framework gave us insight beyond the lake bed, using on ice or on water ground penetrating radar, which allows us to find the most advantageous spot in a lake to find the right sediment for your question. This highly portable system can be walked, skied, paddled, or motored around a lake. Just make sure that the lake isn't too salty. Out of that field, once you're out of the field, data processing is pretty straightforward. So for about a day's work, you can be sure to find the right spot to take a core to answer the question at hand. Finally, Scott took us back to South America to find out what is driving the retreat of the Patagonian ice field. We saw some fantastic footage of the ice field, a lake that drains seasonally by running under the ice, and we made some new friends along the way by networking with locals and taking students up to the glacier. Next, Scott is going to continue this long-term data collection, apply for larger grants, and build on the community network to make science outreach connections in the ice field region. Now I'll hand this off to Emily to make some more connections.
Great, thank you. So before I begin, I would just like to read the University of Maine's land acknowledgement, as the CCI and the university are housed on Penobscot land. The University of Maine recognizes that it is located on Marsh Island in the homeland of the Penobscot Nation, where issues of water and territorial rights and encroachment upon sacred sites are ongoing. Penobscot homeland is connected to the other Wabanaki tribal nations, the Passamaquoddy, Maliseet, and Micmac, through kinship, alliances, and diplomacy. The university also recognizes that the Penobscot Nation and the other Wabanaki tribal nations are distinct, sovereign, legal, and political entities with their own powers of self-governance and self-determination. I think that's pretty important for all of us to recognize, especially, as I said, like the university and the CCI are on Penobscot land. And so to bring it back to the talks, I'm going to briefly connect all of the three talks, take us back a little bit. So each of the students we heard from are researching some challenging topics that haven't been extensively examined yet. The data being looked at includes some pretty deep time records, some with the potential to give insights into the climate many thousands of years ago. And each, like all of us in the CCI, is really trying to get after the same root question. Based on the data available to us, what did the climate look like, and how can we use different data sets and methodologies to flesh out the details whether they may be in ice, sediment, or in the archaeological records of a region. Something each talk pointed to is the importance of being able to recognize the characteristics of a modality or methodology, because they can be context specific and vary from site or region. They also point to the role of technology and interdisciplinary collaboration in progressing our understanding of climate change and engaging and sharing information with the communities being studied, as well as our own CCI community. So with that, I'm going to hand it over to Mark.
Great, thank you, Emily and Joe. I'm going to be introducing the talks for the rest of the session. My name is Mark Royer, and the first presenter for today is Mariusz Potocki. He's going to talk about the world's highest ice core, collection, sampling, and preliminary results.
Thank you, Mark. Let me start with presentation. Can you see my screen? Yeah. Okay. Oops. Okay, thank you, Mark, once again. My name is Mariusz Potocki, and today I will talk about world's highest ice core, its collection, sampling, and preliminary results. April to May 2019, the National Geographic and Rolex Perpetual Planet expedition was undertaken. Multidisciplinary team of 34 scientists conducted fieldwork in Khumbu region and Mount Everest. One of the expedition goals was improving our understanding and resilience of the impacts of climate change in the Everest region through comprehensive studies of climate, its past, present, and future. To help to answer scientific questions and understand more about the changing climate, several researchers from CCI were involved to the project and the Everest expedition. This expedition was the most comprehensive scientific assessment of Mount Everest in history, including biology, geology, mapping, meteorology, and glaciology. This map presents all sampling sites visited during the 2019 expedition. Different colors indicate different type of collected samples. The sampling sites were not only limited to Khumbu Valley and Everest, with these red line shows, but also surrounding valleys and peaks. During this expedition, we drill ice cores in several locations on close to Mount Everest, including Khumbu Glacier here, where is this dark black sign, and at the South Col. As a glaciology team, we also collected surface snow samples, and we collected stream samples in Khumbu and other valleys. In this talk, mostly I will focus on collecting and sampling South Col ice core, but I have to mention why it's so unique. South Col Glacier is located above 8,000 meters. Nobody before drilled at that elevation. It is unprecedented opportunity for science. Opportunity to see the world above 8,000 meters and getting as close as possible and touch the jet stream and ideally find out details about past jet stream and how its location change. Results from all collected ice cores will tell us about past climate, including atmospheric circulation and chemistry, how does trace elements concentration change with time in the region, what is the relative contribution of natural and or anthropogenic sources, help us to determine the impact of industrial activities and or natural sources on the regional atmospheric chemistry of the Himalayas. This view shows the traverse route to the Everest summit. Here is this yellow patch, it's a base camp. The red arrows show the drill site. One is just below the Khumbu icefall and the other one is at the South Col. From base camp, climbers must pass through the Khumbu icefall. They can only traverse this area with the aid of ropes and ladders. Even with all the safety precautions, this section is extremely dangerous. Once through the Khumbu icefall, climbers reach the Camp 1 at the 6100. Travel from Camp 1 to Camp 2 at 6500 takes climbers through the Western Khum. Most climbers must navigate the Khumbu icefall multiple times as they acclimate to the elevation. To work at the high elevation, a proper acclimatization is necessary. The acclimatization is a process of adapting to the decrease in oxygen concentration at a specific altitude. It's required number of changes that must take place for the body to operate with decreased oxygen. Acclimatization is the body natural means of avoiding altitude sickness. The rate of acclimatization depends on altitude, ascent, and it's very individual. My major target was drilling above 8,000 meters. In mountaineering, the death zone refers to altitude above a certain point where the pressure of oxygen is insufficient to sustain human life for extended time span. So this point is generally targeted, as I mentioned, at 8,000 meters. Many deaths in high altitude mountaineering have been caused by the effects of the death zone, either directly by loss of vital functions or indirectly by wrong decisions made under stress or physical weakening, leading to accidents. In death zone and higher, human body cannot acclimatize. The body uses up to its store of oxygen faster than it can be replenished, and extended stay in the death zone without supplementary oxygen will result in its deterioration of body functions, loss of consciousness, and ultimately death. Khumbu Icefall is the most dangerous section on the route to Camp 1 because there is a constant danger of the ice breaking anytime. Most climbers try to cross the icefall during the very early morning before sunrise, when it has partially frozen during the night and it's less able to move. This line of headlamps illuminate the path climbers take up the Khumbu icefall from base camp. Here is a view on the Khumbu icefall. This yellow line shows the route through the icefall in 2019. The most dangerous time to cross the Khumbu icefall is generally mid to late afternoon. And acclimatization is very important. Strong acclimatized climbers can ascend the icefall in a few hours. Before and during the climbing season, dedicated team of Sherpas, called Icefall Doctors, is responsible for finding and maintaining the route through the Khumbu Icefall, and it's changed every season. They owe responsibility of ensuring safety of the climbers by installing ladders across the deep crevasses, fixing ropes and pegs, and maintaining all climbing route. Here, a few different views on the Western Khum, which is above icefall. It's named after Mallory. Khum in Welsh means valley. So here is the view from the Camp 2 to the Lhotse ice wall, where the Camp 3 is located. Surprisingly, the main challenge in the Western Khum is the heat. The valley's structure means there is a little wind, and the intense sunlight at such as a high altitude can make it uncomfortably hot. And the next challenge is climbing Lhotse face, using fixed ropes to get across a sheer wall of ice and ascend to Camp 3 and then later to Camp 4 at 8,000 meters. The South Core, where Camp 4 is located, is the last major camp before climbers make their summit push. Located almost at 8,000 meters, and its first night most climbers spent in that zone. So we planned to spend 2 nights over there, and we dedicated to spend 2 nights because we had to spend all working day there. So Ice Call drilling team, which I was part, had to work on the glacier, and the meteorology team had to erect the, excuse me, a meteorological station. And this red arrow shows the drill site. Next day, after first night at the 8,000 meter elevation, we split it into mentioned 2 teams. the group of 5 Sherpas, one of media team member and myself went to the flat part of the South Col Glacier where with the great help of the Sherpas, I recovered 10-meter core. It was the most stressful part of expedition for me because after this all effort and all preparation, we are not sure that everything works well. And there is pretty much no way to just back down and just get whatever it's needed if something doesn't work. And after this, when we back to Camp 4, late afternoon, I collected also the 2-meter basal ice core. After many field and laboratory tests, we decided to use off-shelf existing COVAX drill system and modify it. Major changes was the power drill and power source. Instead of electric drill powered by generator, that of course would be too heavy and probably would not work at that elevation, we replaced it with heavy-duty battery powered drill. And we tested it before in minus 25 here, especially battery performance. We made other improvements to the drill. We made the holes at the top of the core barrel to help to transfer the ice chips. We installed limiters that push the ice chips to fall in the barrel. And also we modified the drill head, installing the shoe that can regulate the how aggressive is the drilling head. Also, we tested many different type of ice transportation methods. So we prepare plastic tubes, very light ones, and insulated backpacks. After recovering the ice, Sherpas carried down the core to the Camp 2, and then by helicopter it had been transported to Kathmandu and then later to University of Maine. It was a very big logistic operation. Finally, about a year ago, all ice cores collected by glaciology team arrived in Orono. Then we start splitting and sampling cores for different type of analysis. I have to mention that we are a little bit delayed with all analysis because the COVID and part of the labs then being closed. But ice cores have been prepared and sampled for major trace elements, major soluble ions, stable water isotopes, biology, especially DNA presence, been sampled for carbon-14 dating, nitrogen isotopes, and for laser sampling. This plot shows oxygen isotope record from 10-meter South Col. As you can see, the signal is clear and indicate the environmental record, and it's well preserved. For stable water isotopes and major trace elements sampling, we use continuous melting system, and we sampled with about 1 centimeter resolution. The resolution of traditional ice core sampling methods limits the scope of information that can be extracted from the ice core regarding meteorological scale events like storms, particularly in low accumulation and compressed ice. Using laser ablation and novel ultra-high resolution multi-element sampling method of ice cores, we can get the highest resolution continuous glaciochemical record yet from an ice cores, sampling the core with 120 micrometers resolution. Here is the iron profile from the 10-meter core, sampled with 1 centimeter resolution. This one and the other elements records are very well preserved, but to distinguish single years, 1 centimeter resolution may be too low. So not long ago, we started lasering process of the cores. And for example, if we take a look closer to the laser results of the selected here, highlighted in red, 12 centimeter section, we may see even more. So we see 4 group of peaks that telling us there are 4 years in this small section, 12 centimeter of ice. For comparison, here is a copper record. The blue line is showing 220 data points collected by laser, and for comparison in the background you see just 13 samples collected by continuous melting system. So we losing information if we just collect with too low resolution. Initial results and conclusion from our research. The South Col 10-meter and 2-meter ice cores have highly compressed ice layers. Stable water isotopes profiled from the South Col ice cores indicate that environmental record is well preserved. It's a proof of concept for obtaining high resolution profiles of trace elements in annual layer at South Col Glacier. Using the 120 micro sampling resolution capability of our Keck laser lab, we expect to examine sub-seasonal to storm scale signals. The South Col surface is carbon-14 dated at about 2000 years old. And I think I just ran out of time. First of all, I would like to thank you to Paul Majewski, who was an expedition and science leader for 2019 National Geographic and Rolex Perpetual Planet Everest expedition, for involving me into this unique project, and of course for Paul's and Heather's support in base camp, and especially when I were up high, and all climbing partners, especially Panuru and all Sherpa team, media team, National Geographic team, base camp crew, and of course lab friends that proceeding analysis. And there is no time to show short movie, but I'll be happy to take questions. Thank you.
Great, thank you, Mario. Are there any questions?
Yeah, I'm really curious. Did you get a chance to summit?
Paloma, unfortunately not. Our main goal was to collect ice cores. So the major goal was South Col ice core, but also we considered to collect ice core at the summit. But last year, 2019, that was a very special year on Everest. There was like a tremendous crowd up there. So we went to balcony, which is 8,400. Pretty much it's a halfway between South Col and the summit, but we had to give up. It was like a tremendous crowd and we don't want to risk because we would stay too long there in the lines, plus performing drilling that would be way too long. And yeah, that would be way too dangerous. So yeah, first of all, to stay safe. So thank you.
Are there any other questions? Okay. Thank you, Mario. Our next speaker is Vendi Hazukova, and she will talk about summer phytoplankton dynamics.
All right, thank you. Ah. Oh, big storm. I'm sorry. Okay, thank you, Mark. I'm gonna share my screen. Can you see now? All right. So thank you for the introduction. I think it's hard to top the Everest, but Greenland is pretty cool as well. So I'm going to be talking about what factors drive phytoplankton abundance under ice and why should we even care about it. Oh, all right. So for a long time, people have thought that lakes really do nothing under ice and that it doesn't really matter, they are kind of sleeping. But we are getting more and more evidence that lakes are actually active under ice. And one of the pieces of evidence we have is large amounts of greenhouse gas emissions upon ice out, which suggests that lakes are biogeochemically active under ice. Another thing why we should study lakes under ice, especially now, is because lakes are melting earlier during the year as a result of warming. So if we don't understand what actually happens under the ice, it will be really hard to predict what will be the consequences of earlier ice out. So, and why phytoplankton? Well, phytoplankton performs primary production, photosynthesis, so they are affecting biogeochemical cycling quite a bit, and they are uptaking the inorganic carbon that could potentially be released from the lakes upon ice out and produce oxygen. And meanwhile, they also cycle nutrients and other elements in the water. So to begin, I would like to kind of summarize how different actually the conditions are when we consider that lakes are ice covered versus the open water season. So one of the easiest thing to look at is temperature, right? During the open water season, temperature is usually higher versus the ice covered season when temperature is low, usually between 0 and 4 degrees. The ice cover is also presents kind of distinct environment in the lake because it prevents connection of the lake to the landscape. So you don't really have a gas exchange at the air-water interface. So no oxygen can come in from the atmosphere and no carbon dioxide can come out of the lakes to the atmosphere. Also, it prevents organic matter from the lakes from coming to the lakes. And one of the biggest things that is really important for phytoplankton, because they need light for photosynthesis, is that it prevents light from penetrating deeper into the lake water. As the lakes are covered with the ice, there's also a lot of mineralization going on of the organic matter that accumulated the previous season before the ice went on the lake. So if we want to talk about phytoplankton dynamics during the season, we need to consider dynamics of resources. And what is really important for phytoplankton are nutrients and light. So as I said, there is mineralization going on under the ice cover. So we are assuming that nutrients are actually not really limiting for phytoplankton under ice. And we can have quite a bit of phytoplankton under ice if nutrients are okay. But we also have to consider light. And that can be a big deal during the ice cover period because it prevents the light from coming in. So if we have nice clear ice that doesn't really scatter light that much, there can be quite a bit of penetration and potentially a lot of phytoplankton biomass. But ice can have incorporated dust into it or some soot or even snow on top of it. And those factors would definitely make the penetration harder and scattering more. So there would be very little phytoplankton in the lakes. What else can prevent light from penetrating into the lakes are solutes that are inside the lake water. For example, that could be quite a lot of organic matter in the lakes that could have color and absorb more of the light and then hamper growth of phytoplankton even more. So as I said, we should talk about phytoplankton because it has some important implications for carbon cycling and emissions upon ice out. So if we have a lot of phytoplankton under ice actively performing photosynthesis, they will be releasing oxygen into the lakes while they are ice covered and they do not have access to the atmospheric oxygen. If there is very little phytoplankton going on and phytoplankton growth going on, the respiratory processes and heterotrophic processes might prevail and then lead to high amount of greenhouse gas emissions upon ice out from the lakes. So our question was, how does phytoplankton biomass change throughout the season and between lakes with different DOC concentration? Because we are assuming that DOC is actually going to be quite important in shaping the in-water conditions and changing the light environment. So we studied 2 lakes in Greenland, here in West Greenland near Kangerlussuaq. And we selected one lake, Lake SS2, that has very high DOC concentration, and Lake SS901 that has low DOC concentration. They differ for approximately 4-fold. And we measure DOC, but it is a proxy for the amount of dissolved organic matter in the lakes. So it also means that they are changing in nutrient concentration because the organic matter includes carbon, but also organic nutrients. Presence of the DOC also affects transparency of the lakes. So what we did is that we sampled the lakes over the course of ice-covered season all the way to open water season in July. And during the winter, we augered a hole into the lake and deployed automatic samplers that were measuring light, oxygen, and temperature all the way through the monitoring season. And we also collected manually some samples at 3 depths under ice and during the open water season via boat. And we collected samples for phytoplankton, zooplankton, nutrient analyses, DOC, and also pigments. As I'm going to be showing you the results, I'm going to be kind of pooling the samples that we collected to the ones that were collected under ice, very early after the ice out and during the open water period. So here are the results, and bear with me. There is a lot going on, but let's have a look at the left side of the results. On the y-axis, we have density, so the amount of phytoplankton in the water, and on the x-axis, we have time. So we are starting here under ice in April and going into the summer. This is the high DOC lake on the top and low DOC lake on the bottom. And we see that in the high DOC lake, there's very little going on in terms of phytoplankton under ice, but once the ice melts, there is a huge peak, and we are on the log scale, so it's an order of 3 magnitudes increase. When we look at the low DOC lake, there's actually quite a bit of phytoplankton under ice, and it doesn't really change that much as we go to the open water season. And very similar pattern we get when we look at pigments, which also kind of represents total biomass of phytoplankton, and different composition of pigments can even give us an idea of what taxonomic composition of phytoplankton do we have. And again, this is the high DOC lake, very little going on under ice, and a huge spike during the open water period. And while lower concentration, there is much more even, I guess, relief of the concentrations of pigments in the lake water over the course of the season. And these are some of the data we collected with the high frequency sensors under ice. So we are starting in April, here are ice outs, and this is July. And we see that in the bottom of the lakes, dissolved oxygen is actually fairly high in the low DOC lake in blue. And it doesn't really change that much even after ice out. When we look at the high DOC lake, it's anoxic the whole under ice period, and then it gets oxygenated once the contact with the atmosphere is renewed after ice melt. So why could that be? We are kind of trying to explore some mechanisms that are involved in these patterns. And so we did some preliminary correlations because obviously we have limited data, but it appears that the relationship between phytoplankton density under ice is negative with DOC concentrations. So that means that the higher DOC, the less phytoplankton we have under ice, but the relationship reverses as we get to the open water period, and it's positive. So higher DOC, more phytoplankton. Here we have absorbance at 380, which is kind of a proxy for color of DOC. And here we see same pattern, high color under ice, low phytoplankton, high color under during the open water period, high density. But the relationship is much less tight. So to understand why would DOC be important, and as a proxy organic matter in the lakes, we have to kind of consider what organic matter can do in the lakes. It's kind of a dual agent. So if it's colored, if we have a lot of fresh DOM or organic matter that hasn't been really worked on that much, it can cause a lot of light attenuation, especially at high concentrations, which we kind of see in our lakes. As it gets worked on by microbes and also by solar radiation, it can become less colored, but also releases the organic nutrients that are associated with the organic matter. So here are some data that we collected on concentration of carbon, concentration of dissolved organic carbon, and also color. So here in blue, we are seeing values that concentrations under ice, and they are getting progressively lower as we get to the midsummer season in July. Similar pattern we can see with color, high color under ice, but it's decreasing towards the open water season. And also note that the concentrations are really different between the high DOC lake and low DOC lake. So these, all these results together would kind of suggest to us that high DOC under ice with high color would lead to light attenuation under ice and limit phytoplankton growth in the high DOC lake. However, in the low DOC lake, there's not really that much DOC to attenuate the light so phytoplankton can grow. However, during the open water season, a lot of the DOC is being worked on, and you're having nutrients being released, which subsidizes the phytoplankton growth in these very oligotrophic, low nutrient lakes. So just to show you some how it could look like in real life, we have ice-covered lakes, some mineralization of old accumulated organic matter from previous season is going on. And during the ice melt, when the lakes are starting to mold and the permafrost is starting to thaw, you're getting a flux of fresh organic matter into the lakes that is fairly colored, as you can see here. And later on, as we are warming and everything is dry, it is very dry tundra, so the lakes do not have that much hydrological connectivity. The lakes are very clear because of photobleaching, because of the presence of solar radiation and microbial degradation that decreases the color and releases nutrients that are more available to phytoplankton. So just to summarize, we are seeing high under ice biomass in low DOC lake under ice, which suggests importance of that period for clear lakes in the Arctic. And we are seeing high biomass in high DOC lakes during the open water periods, likely as a result of nutrient subsidization. And because we only have 2 lakes and limited number of samples, this is all very correlative and speculative. We obviously have some data to back it up, but we will also conduct an experiment to kind of disentangle the effects of shading and nutrient subsidization for phytoplankton in lakes next time we get into the field, if we ever do that. And we saw that there's a potential for emissions upon ice out because one of the lakes had high oxygen under ice and the other one was anoxic. And that study is still in progress, and I will hopefully have some more later. So that's all. Thank you very much. I would like to thank Jasmine for being great, and Ben for helping me, and other people that helped me on the way, lab members past and present, and University of Maine for funding, and also the Kangaroo Shack Station for logistical support. And that's all. Thank you very much.
Great, thank you, Vendi. Are there any questions?
I can ask a question if no one else has one. Have you thought about how warming might affect this?
Yeah, so I think that's kind of the underlying idea behind this project in general, because the lakes are going to be, the ice is going to be melting earlier and earlier. But for that, we need multiple different seasons of data collection, which is something we are working on, but I'm just showing data from 2019. So I can't speak to that yet, but hopefully I will soon. Also, warming is affecting processes during the open water season, not just the under ice and the carryover between seasons, but like stratification is going to change, which is also going to have implications for resource dynamics in the lakes and phytoplankton and gas exchange.
Thanks.
Are there any other questions? Okay, great. Thank you, Vendi.
Thank you.
Thank you, everyone, for dealing with the storms that we have going through our area right now. Okay, our next presenter is Suman Acharya, and he's going to talk about, he's going to have a review on the roles of renewable energy technologies in climate change adaptations and mitigation among rural communities of Nepal.
Yeah, thank you, Mark. I'm going to share my screen. Is my screen working well? Okay, yeah, thank you. I'm Suman, and I'm a PhD student in anthropology and also Climate Change Institute. I'm going to talk briefly about the review on the roles of the renewable energy technologies in climate change adaptation and mitigation among rural communities of Nepal. So this is not, so this project, does not align with my dissertation, but this is the project that I wrote for the INT 500 class from the Climate Change Institute, instructed by Dr. Catherine Glover. So I'm happy that I was able to complete the paper and also submit this paper into the journal, so which is under the review. A good news for me. Yeah, I was planned for my field work last summer, but I couldn't do that. Hopefully, we all will be able to go to the field work next summer. Okay, starting with my presentation, the outline is, so I will be briefly talking about the background and objectives of this study, and then following with the status of the national energy consumption in Nepal, and also the important renewable energy technologies in Nepal, and what are the benefit of the renewable energy technologies in rural Nepalese community. That's in terms of climate change adaptation and mitigation, and also some future research recommendations. Okay, talking about the climate change and energy in Nepal. So Nepal is one of the highly climate vulnerable nations in the world, and it is vulnerable due to both the biophysical and also the socio-political and economic aspects of the climate stresses. So in this paper, I will be highly focused on the socio-political and economic aspects of the climate change and adaptation. So why Nepal is highly vulnerable to climate change? Because it depends on those resources which are highly climate vulnerable. For example, more than 80% of the total population of Nepal are dependent on agriculture and natural resources for their daily needs, including energy. And these resources are highly vulnerable from the climate change. So Nepal is the major victim and also confronts energy security problem due to the lack of resources, climate changes, and poverty, political instability, and lack of technological knowledge in the rural areas. So at this time, Nepal is dependent on the non-renewable energies, and also there is the high culture or practice of the conventional energies that has promoted the climate vulnerability among the rural communities of Nepal, and also the conventional practices of the renewable energy technologies like firewood and some others are playing a role in the production of the greenhouse gas emissions. Nepal plays a very negligible role in greenhouse gas emissions, but also the bad choices or the conventional forms of energy have played a small role in the greenhouse gas emissions. So there is a cause and effect relationship between energy consumption and climate change. So this review shows that the cleaner the choice of the energy, the lower the production of the greenhouse gas emissions, and the more use of the non-renewable energy like the fossil fuels and some other, the higher the chances of the climate change. At this time, Nepal is slowly transitioning to the different modern renewable energy technologies. Like we can see here in the picture that people have been transitioning their older form of cooking stoves to the improved cooking stoves, and also the micro hydro power is very popular in Nepal at this time. Solar energy and other windmills are gaining its popularity at this time. So I talk here climate change mitigation in terms of the reduction of greenhouse gas emissions, whereas climate change adaptation in terms of generation of alternative income, supporting education and health facilities, enhancing social capitals, etc. So this I will be talking in the later part of the presentation. Nepal has a higher potentiality and also the capacity to generate energy from different renewable resources, but due to different constraints, it has not been able to do that until this time. And also the scientific study of the potentiality, opportunities, and benefits of the renewable energy technology is lacking in Nepal. So within these gaps, so I tried to I tried to review and analyze the national energy consumption, renewable energy types, and their potentiality in climate change adaptation and mitigation in Nepal. So I tried to use the some peer-reviewed journals and also the annual reports from different organizations, and also the progress report of government for a few years. So talking about the status of national energy consumption in Nepal. So Nepal is highly dependent on biomass energy, like the fuel wood, agricultural residues, and the cattle dongs for the energy. So it accounts for the 78% of the total dependence of the energy. That's the biomass. And the use of the petroleum accounts for 12%, whereas 4% of the energy is generated from the coal, and only 3% of the energy, of the total energy, is generated from the modern renewable technologies, and also from the grid electricity system. So we can clearly see that there is the lack of the well-organized national grid systems. So in terms of the energy consumption by sectors, so the residential sectors or the household sectors account for the largest proportion of energy, with the 43% of the total energy consumption, followed by the industrial sector, that's 38%, and the trading sector, 7%. Yeah, this figure shows the same data as. So I will be talking briefly about some of the important renewable energy technologies and their potentiality in Nepal. So firstly, talking about the solar energy. Solar energy, it's getting quite, it's getting a quite popular height in Nepal at this time. So Nepal geographically situated in a higher altitude, and also with the larger number of sunny days per year, like receiving a good amount of solar energy. Its solar energy is getting a popular height there. So the excuse me, the average sunshine hour per day intensity of solar insolation with the ranges of 3.9 to 5.1 kWs, kilowatt hours per meter square per day, is 6.8 hours, which is the good amount of energy received every day. And with this potentiality, so the total commercial potentiality of solar technology for grid connection is about 2100 megawatt in Nepal. And the solar energy has a high potentiality in four major types. That's the grid connected PV system, and the solar water heater, solar lanterns, and solar home systems. And also the solar energy is getting cheaper around the world, and also in Nepal. So it's so the people has started using this, and also the prices of the solar energy is predicted to be reached by the 60% in the next decade. So approximately now talking about the hydropower, Nepal has a good amount of water resources. So it accounts for 2.2% of the global total water resources. And also it is rich in the river systems, although the country is very small, like 6,000 rivers. And there are 88 hydropower projects working at this time. And the 30 largest hydropower stations that account for the 15% of the country's total energy potentiality. And Nepal is quite famous for the micro hydro power of grid system. So in the 7 years time of 2007 and 2014, it has been able to establish around 400 small scale micro hydropowers that supported about 150,000 rural families in Nepal, which is a good amount. And but unfortunately, still 6.6 millions of the people of Nepal are deprived of the electricity, because in the rural areas and also in the mountain areas, there are several places where the people living in those areas lack the electricity. Now, talking about the biomass energy. So as we have already discussed that agriculture, forest, and livelihood are the primary resource of energy production in the rural household. So these energies are used for, especially for the cooking purpose every morning and night. And At this time, uh, the country has been able to install a large number of improved cooking systems that are made by both mud and metals. So here we can see the data of the improved cooking system made from mud and metals, and these are very effective in reducing the indoor air pollutions. So there was a record of around 7,500 people dying in Nepal with the problem of indoor air pollutions. So improved cooking system has been helping to reduce this number. And also this helps for the rural women and children to save their time and to utilize it for other purposes like alternative income generation, and also for children to use their time for the uh, education. Yeah, and in this way they have been helping in the climate change adaptation. I will be highlighting this again. Also, the biogas and improved cooking systems are successful as adaptation-based organizations are promoting financially and technically in those areas. So this time there are different organizations, both national and international organizations working in the climate change adaptation in the rural Nepal, and they have been helping to promote the improved cooking system and also other different renewable energy technologies. So they are gaining good height at this time. Now talking about the wind energy, uh, there is very low expansion of wind energy in Nepal. However, the high mountains are very potential for the production of wind energy. So the lack of the road access in the rural mountains, and also due to the complicated geography, also the lack of infrastructures and the technological knowledge, the wind energy is not getting good popularity in Nepal. Uh, so here is the table that shows that the estimated renewable energy potentiality of Nepal. Some of the important renewable energy technologies like micro hydro power and domestic biogases, solar energy, improved cooking system. So they have a good potentiality. So yeah, and also a good coverage around the Nepal. For example, the micro hydro, it has the potential to the coverage of 55 districts in Nepal. So among 55 districts have a potentiality for the micro hydro power. And so we can see the solar energy has a good potentiality of 2100 megawatts, and the improved cooking stoves. So the potentiality is like 2.5 million number of improved cooking stoves. So this will really make a good progress in the climate change mitigation and adaptation among rural households. And also the wind energy having a good potentiality. So less than, I mean, 10% of the area has been able to use this. So yeah, that's the potentiality of these renewable energy technologies. Uh, so how the mitigation has been supported by the renewable energy technology. So I have talked here in terms of the greenhouse gas emission reduction. So the papers that I have reviewed has shown that the traditional fuel would have been replaced by improved cooking system stoves and the biogas. So this helped in the uh, reduction of the greenhouse gas emissions. Also, the conventional use of the forest uses and has lower the emissions. So also the people have transitioned the use of the petroleum products and replaced by the electricity and solar energy. So these all accumulatedly helped in the greenhouse gas emissions. So here's a table that shows that uh, for four important renewable energy sources and their potentiality in reducing the greenhouse gas emissions. Also, while people are transitioning to the renewable energy technology, the use of the forest resources and has really reduced, and this has helped in the forest expansion that help in the carbon sequestration. So also the country's national data has shown that the forest area of Nepal has been increasing in the last few years. So this helps the evidence. So some of the climate change adaptation strategies are, so in the paper I have highlighted in 4 different important sections, but here I'm talking in general. So it's helping to reduce the indoor air pollution and also reduce the respiratory and eye disease among the women's though who are working in the kitchen every day and night in the fuel load, and also the it has helped to reduce the amount of malnutrition. And in the education sector, the replacing of the candlelights and by candlelights with the other forms of source of energy has helped the school children to go to attend the education and help them to adapt to the climate change, and also the time saving of the women and children so that they can use in other income generation activities has helped the rural women to adapt with the climate change. And income generation activities like these organizations which have been promoting the renewable energy technology has created the income generation activities among rural people. So this has helped also helped in the climate adaptation among the rural people. Uh, Also, the social capitals have been enriched, and the economic benefits like the cheaper resources and carbon trading, energy conservation, and the local entrepreneurship and business have been promoted due to the implication of the renewable energy technology. So here is the example how country has earned the revenue from the certified emission reduction under the clean development mechanism in the 2017 in the fiscal year 2018-2019. A good amount of revenue have been collected. And so some of the recommendations for the future research are from this project are like I found that a very few studies on these topics have been done in Nepal. So the opportunity and challenges of renewable energy technology in relations to climate change adaptation and mitigation is a need at this time. Also, Nepal has entered to a new system of political governance. Thus, study on decentralized system of energy production and consumption is a need. Also, the potentialities and barriers of promoting renewable energy technologies in the new political regimes of Nepal is a need. So as there is the high potentiality of generating different energies like wind energy, solar energy, and micro hydropower, the government at this time need to prioritize these, and also the detailed assessment study and should be done for these important energy technologies, and also make a separate plans for each of these for the scientific study, because during my study I couldn't find the plans and also the government's reports for the different energy. So I recommend this. So I would like to acknowledge Dr. Catherine Glover, so who helped me to think about this project and also to complete my project, and also Dr. Suraj Upadhyay and Dr. Cindy Eisenhower for helping me and also motivating me for this project. Yeah, thank you. Any questions?
Okay, thank you, Suman. I think we went over a little bit of time on the last talk. Perhaps we can take questions with you after we're concluded here. I'd like to take a moment just to thank all the presenters for today. And then would Dan Sandweiss like to give us some closing remarks?
I would. Thank you very much, Mark. So starting with Mariusz, he showed us a new way to get high while studying climate in Everest. This was a snow job, but the core work had Mariusz and his colleagues sinking their teeth into deeper climate history by drilling a cavity into the highest ice core yet sampled at 8,000 meters above sea level. His review of the dangers of working at this altitude left me breathless, but Mariusz and his colleagues seem highly resolved to make the results worth the risk. Vendi appropriately first, I appreciated that, even though Greenland is very cool. There she's studying phytoplankton under ice, on the rocks as it were, and the neat things that can happen when there is no ice. Examples, different conditions seems appropriate in a lake. Vendi found significant differences between high and low DOC lakes and shed light on the potential reasons for this pattern. Suman gave on renewable technologies in Nepal, which currently depends on non-renewable energy with negative outcomes. He showed that Nepal is really off the grid when it comes to energy consumption, and that like politics, all or most is local. He presented a sunny picture of the potential for solar energy to improve the situation. However, Nepal has been able to go with the flow using hydropower, but more is energy production is a burning issue in which progress has been made. Finally, lots of energy is blowing in the wind if the country chooses to turn that way. In terms of reducing greenhouse gas of RETs, they will really be cooking with gas. Thank you. See you all next week.
Bye.
Have a great Thanksgiving.